Case of proportional taxes and transfer payments. Till now, we have assumed that the government imposed taxes do not depend on income. That is, its lump sum taxes is equal to T. But in real world, taxes are a function of income. A more realistic assumption would be that the government collects a constant fraction T of income in the form of taxes, so that new tax equation is T is equal to Ty. We have also assumed transfer payments from government to be zero. But in real world, the government transfer payments, that is TR, result in form of subsidies, free health care, loan waivers, etc. So we have to deduct TR from the tax equation. Net tax payment from household will be T is equal to Ty minus TR. The consumption function with proportional taxes and constant transfer payments is given by C is equal to A plus MPCYD. C is equal to A plus MPC multiplied with Y minus Ty minus TR. C is equal to A plus MPC multiplied with Y minus Ty plus TR, which results in A plus MPC multiplied with 1 minus T multiplied with Y plus MPC TR. We note that proportional taxes not only lower consumption at each level of income, but also lower the slope of the consumption function. The MPC out of income falls to 1 minus T. The new aggregate demand schedule, AD, will have larger intercept but is flatter as shown. Now we have AD is equal to A plus MPC multiplied with 1 minus T multiplied with Y plus MPC multiplied with TR plus I plus G, which results in A plus MPC multiplied with 1 minus T multiplied with Y, where A is autonomous expenditure and equals to A plus MPC multiplied with TR plus I plus G. Currently, our expenditure multiplier equation, that is 1 divided by 1 minus MPC, is only dependent on consumption. Let's now extend our discussion and add additional dimension to the equation of expenditure multiplier by adding tax rate plus transfer payment and variable domestic imports as a function of income. Broadly, both income taxes and imports shrink the multiplier since they act as a leakage to overall income of the economy. Technically, imports and income taxes reduce the slope of the AD curve. Now, let's figure out the multiplier equation. For that, we have to find income. As we know, income determination condition in the product market is Y is equal to AD. Since AD is equal to A plus MPC multiplied with 1 minus T multiplied with Y, we can rewrite same equation as Y is equal to A plus MPC multiplied with 1 minus T multiplied with Y. Solving for the equilibrium level of income, Y minus MPC multiplied with 1 minus T multiplied with Y, which equals to A. Y is equal to A divided by 1 minus MPC multiplied with 1 minus T. So that the multiplier is given by 1 divided by 1 minus MPC multiplied with 1 minus T. Comparing this with the value of the multiplier with lump sum taxes case, we find that the value has become smaller. When income rose as a result of an increase in government spending, in the case of lump sum taxes, consumption increased by MPC times the increase in income. With proportional taxes, consumption will rise by less. MPC minus MPC multiplied with T, which equals to MPC multiplied with 1 minus T times the increase in income. Let's see it through one example. Assume that the marginal propensity to consume is 0.8 and the tax rate is 0.25. What will be the impact of increase in government spending by $100 with and without tax rate? In case 1, that is without tax rate, expenditure multiplier will be 1 divided by 1 minus MPC, that is 1 divided by 1 minus 0.8, that is 1 divided by 0.2, which is equal to 5. So, $100 increase in government spending will result in $100 multiplied by 5, which is equal to $500 increase in overall output of the economy. In case 2, that is with tax rate, expenditure multiplier will be 1 divided by 1 minus MPC multiplied with 1 minus tax rate. Clearly, in this case, consumption will now rise by less amount, that is 0.60, which is a result of MPC multiplied with 1 minus T, that is 0.8 into 0.75 for every unit increase in income instead of the earlier 0.80. Thus, consumption will increase by less than before. The government expenditure multiplier will be 1 divided by 1 minus 0.8 multiplied with 1 minus 0.25. That is 1 divided by 1 minus 0.8 multiplied with 0.75. That is 1 divided by 1 minus 0.6. That is 1 divided by 0.4, which results in 2.5, which is smaller than that obtained in the earlier case. So, if government expenditure rises by $100, output will rise by the multiplier times the rise in government expenditure. That is, by $100 into 2.5, which results in $250. This is smaller than the increase in output in the earlier case.